Experiences of collaborative work in academic networks, presented by Arturo Torres-Bugdud, Agustín Guadiana-Coronado, María Blanca Elizabeth Palomares-Ruiz, and Jesús Guadalupe Castañeda-Marroquín. Today we will be presenting about our project, of which it was developed jointly by the Autonomous University of Nuevo León in Mexico and the Cesar Vallejo University in Peru. It applies the collaborative online international learning model, known as COIL, to strengthen engineering education through international collaboration, digital learning, and intercultural teamwork. Higher education faces the growing challenge of preparing professionals capable of functioning in globalized technological and multicultural environments. In the field of electrical engineering, this means combining strong theoretical knowledge with practical skills while adapting to new technologies and sustainability demands. According to Hugh and colleagues, mastering the operation of three-phase induction motors is essential to understanding modern industrial systems. To meet these needs, our project implemented the COIL methodology, as described by Rubin and Guth and Salas Pilco, which connects universities through virtual collaborative courses. This allowed us to design a shared learning experience that links technical knowledge with intercultural collaboration. Engineering programs traditionally emphasize local or regional applications, often overlooking the importance of international perspectives. Of course, this limits students' exposure to different cultural and professional contexts and reduces their readiness for a globalized labor market. Our central question was, how can we train engineering students to think globally while working collaboratively online? Through this mirror course, we sought to bridge that gap, allowing students from Mexico and Peru to learn together, exchange ideas, and jointly solve technical problems using virtual platforms. The COIL model has been successfully implemented by more than 100 universities worldwide, including SUNY in the United States, the Politécnica de Madrid in Spain, and the Tecnológico de Monterrey in Mexico. Research such as Troncoso shows that COIL promotes intercultural understanding, academic achievement, and employability. Similarly, the Erasmus Virtual Exchange Program demonstrated that online collaboration is an effective and inclusive strategy for internalizing education. These global experiences provide the foundation of our own initiative, connecting Latin American universities through a course focused on three-phase induction motors. The primary objective of this project was to strengthen the understanding and application of three-phase induction motors in industrial systems while developing teamwork and digital collaboration skills. We also aimed to innovate teaching practices by introducing international cooperation and to contribute to the broader goal of curriculum internationalization in engineering education. This design of educational project was based on the AD model, of which is named after analysis, design, development, implementation, and evaluation, of which was combined with Kolb's experiential learning theory. This methodological framework provided structure and flexibility, ensuring that learning outcomes were both measurable and meaningful. It also guided the collaboration between professors from both universities, promoting co-creation of learning materials and joint reflection on teaching strategies. During the diagnosis and planning phase, both institutions met to identify common curricular goals and opportunities for collaboration. This meant by having multiple teams calls, multiple classroom calls, having strategizing each other's works, just so they could find the common material on implementing their studies. The content was aligned with the European Commission's 2019-1781 regulation on high-efficiency electric motors. In a design and development stage, teachers created shared objectives, materials, and rubrics covering topics such as equivalent circuit analysis, no-load and locked rotor tests, and energy efficiency standards. Finally, in the implementation phase, students from both universities participate in synchronous and asynchronous sessions, combining theoretical analysis with virtual laboratory simulations. Finally, during the evaluation, perception surveys were used to assess students' technical understanding and intercultural growth. The mirror course was delivered simultaneously at both universities through platforms such as Microsoft Teams, Moodle, and Google Classroom. Students were grouped in binational teams and tasked with solving real industrial problems. They analyzed the performance data from induction motors, prepared joint reports, and discussed their findings in virtual forums. Teachers, in the meantime, coordinated each activity, documented progress through reports and attendance lists, and held debriefing sessions to evaluate results and suggest improvements for future editions of the course, of which, starting 2025, a few professors of the Autonomous University of Nuevo León, will be attending the school directly at Peru to teach induction motors to their fellow students. Students reported significant development of intercultural and communication skills, especially when working with peers from a different country. They also deepened their understanding of global applications of three-phase induction motors and became more proficient in using digital tools for technical collaboration. Many expressed that this was their first experience working in a truly international academic setting, one that helped them build confidence, adaptability, and problem-solving capacity. In the meantime, for our fellow teachers and institutions, for faculty, this project encouraged innovation in teaching and the exploration of new pedagogical methods. Both universities achieved progress in their institutional goals of curriculum internalization, offering students a global learning opportunity without physical mobility. Additionally, this collaboration opened the door to joint research projects, the exchange of the best practices, and the establishment of stronger academic networks between both universities. To conclude, the coil-based mirror course demonstrated that international collaboration can successfully enhance both technical and intercultural competencies in engineering education, as well as the collaboration between both academic teams from both universities and the teams within the Autonomous University of Nuevo León to collaborate each other in the creation of using the coil-based mirror course. It showed that online exchanges can be rigorous, inclusive, and impactful when carefully designed. Beyond academic learning, the project fostered long-term professional relationships and set the stage for continued cooperation among Latin American institutions. Ultimately, this experience represents a step forward toward a more global, collaborative, and innovative model of higher education. Well, I like to hear other references.